Good day everyone, this is our presentation, Packet Flow in a Network. In this presentation, we'll be discussing how a data packet travels from a PC to a server and back.
What is network? A network is a system of interconnected devices, computers, or entities that communicate and share resources. In computing, a network allows multiple devices to exchange data, making communication and collaboration easier and more efficient. One common type of network is the wireless network or Wi-Fi. This network connects devices without physical cables. A great example of this is when a smartphone connects to a home Wi-Fi router, allowing users to browse the internet wisely.
So, after understanding what network is, let's talk about the components on a network. First is the network host. In networking, a host is any device connected to a network that can communicate with other devices. It acts as a source or destination for data. A host can be either a client or a server, which is the client siya yung mag-i-initiate ng requests or services na naghahanap ng information and data, while the server is the one who receives the request and siya ang nagpro-provide ng required information, data, or services na hinihingi ng client. Later, we will demonstrate how packet data travel through our network, where we use a PC as the client and a web server as the server, and vice versa.
Next is a network switch. As shown in the diagram below, the switch is connected between the two devices. Its purpose is to forward data packets directly to the destination device. Switches operates at layer 2 of the OSI model, using the MAC address table to map device connected to each port. When switch receives a frame, it checks the source MAC address and adds it to the table. To forward a frame, the switch looks up the destination MAC address in the table and sends the frame to the correct port. If the destination is unknown, the switch floods the frame to all ports except the one from which it was received.
Last is the router. As you can see, I also included a diagram to help explain the role of a router more easily. In this diagram, we have two routers labeled R1 and R2, whose purpose is to connect multiple switches, meaning a router is a device that connects two or more packet switch networks and forwards data packets between them. Similar to a switch, a router directs data, but the key difference is yung switch gumagamit siya ng MAC addresses to forward packets within a network, while yung router ang ginagamit niya ay IP addresses to route packets between different networks. Routers operate at layer 3 of the OSI model, reading the source and destination IP addresses in the layer 3 header to determine the best path to end-to-end delivery. Routers use a routing table that stores path to known networks and identifies the next hop or interface to reach the target. The primary role of a router is to act as a traffic controller, ensuring the data reaches its intended destination and analyzing and directing packets.
So this is the network that we will be using for this presentation and also the network na ginawa namin. So it consists of a PC, two routers, two switches, and a server. And bawat device dito ay merong unique IP and MAC address. So for PC to server, ang step 1 natin is PC to router 1. The user initiates a request. For example, like they're trying to access a website. Itong request na to, magiging siyang data packet which contains important addressing information. And ang source IP address is 192.168.1.100 na it belongs to the PC. Tapos ang destination niya, IP niya ay 142.250.72.78 which corresponds to the website server. Tapos ito ding packet na to, kasama rin dito yung MAC address. Ang source MAC address ay yung AABBCCDDEEFF, and the destination MAC naman ay yung 112233445566, which is router 1's MAC address. So additionally, meron tayong source port na naka-assign para dito sa request na ito, which is yung 54321. Tapos ang destination port niya ay yung 443 na ginagamit para sa mga HTTPS communication or request. At itong lahat ng info na ito, ang packet ay manggagaling from the PC hanggang sa router 1. Makikita naman natin dito sa video, nagsimula siya sa PC to the switch to router 1. Then the second step, router 1 to router 2. So router 1 receives the packet, updates the source IP. So as router 1 receives the packet, magpe-perform siya ng NAT or yung Network Address Translation para mapalitan yung source IP. Instead of paggamit ng yung private IP na 192.168.1.1.100. So, papalitan niya ito nung sarili niyang public IP na 20.0.113.5 bago ni i-forward yung packet. And the new source MAC is yung 11 hanggang 66. And the destination MAC ay nabago, which is yung 22 na. Tapos, ang nasa dulo na niya ay yung 11. Hindi katulad nung dati na 11 na natatapos sa 66 kasi it belongs to router 1. Pero, same pa rin yung destination IP niya, which is yung 142.2.50.72.78 para ma-ensure na yung final recipient natin ay yung server para malaman na yun pa rin yung destination niya. Tapos, additionally, the source port became 61,000 from 54321 while keeping the destination port as 443. And now, the packet is forwarded to router 2. As we can see naman, isang diretso lang siya dyan. From router 1 to router 2. And lastly, yung router 2 to server. So, router 2 receives the packet and sends it towards the server. So, prepare niya itong isend yung packet to sa final destination, which is yung server. I-maintain ito yung source IP. It keeps the source IP as 203 and the destination IP as 142. Tapos, ma-update ulit yung MAC address niya. Ang bago niyang MAC address ay 22446688331 which belongs to router 2. And ang bagong destination MAC niya ay yung 01234567889 AB na nagbe-belong sa server. Tapos, yung source port naman niya, magre-remain as 61,000. And the destination port stays for like 443. So, after niya mag-update, itong router 2, isasend na niya yung packet dun sa server. So, we can see dito sa video. From router 2 to the switch to the server. Which would complete the journey ng request from PC to the website's host. And ito na nga yung full video ng packet from PC to server. And as you can see, simula siya sa PC to switch, then to router 1, mag-update to router 2, then to switch, then to server. Yan.
So, explain ko kung paano ang pag-travel ng isang data packet from server papunta sa PC. So, step 1, server to router 2. Yung server, which is a source IP na 142.250.72.78 is magsasend ng data. Since malayo yung PC, the destination IP ng PC is 192.168.1.100, hindi siya direct na makakarating. Kaya dadaan muna siya sa network. Ang server ang magsasend ng packet kay switch 1. Si switch 1 naman ay check ang MAC address at ipapasa kay router 2. Step 2. Router 2 to router 1. So router 2 receives the packet and checks the destination IP 192.168.1.100. Bago niya ipadala, babaguhin ni router 2 ang MAC address. Kasi dapat ang next hop na device ang may correct na MAC address. So ang new source MAC ng router 2 is 224466883311. Tapos ang new destination ng MAC router 1 112233445566. So dadaan ang packet sa serial links SE000 papunta kay router 1. Step 3. Router 1 to PC. So router 1 receives the packet and checks the destination IP. And router 1 recognizes that the destination is in its local network. So nasa router 1 na ang packet. So kaya babaguhin niya ulit ang MAC address para ipadala ito sa final destination. So, yung new source MAC, which is router 1, is 11.11.22.33.44.55.66. Tapos yung new destination MAC, which is PC, AA, BB, CC, DD, EE, and FF. So, ipapasa na ni router 1 ang packet kay switch 0 at si switch 0 naman ang magdi-deliver nito kay PC. Step 4. PC receive the packet. If PC, check if the destination MAC address matches its own, which is AA, BB, CC, DD, EE, FF, then the PC process the data or ilo-load na niya yung mga web page or files. So, yung server is magsasend ng packet kay switch 1, pupunta siya sa router 2, pupunta siya sa router 1, pupunta siya sa switch, and pupunta siya sa destination which is PC.
So here's the full video of the network on how the data packets traverse from server to PC. First, the server sends the data on the switch. Then the switch forward the data to router 2, and the router 2 pass the data on router 1, and router 1 pass the data on switch. Then the switch forwarded back the data, and lastly the PC receives the data that server sends.
And that's all. Thank you. We hope you understand how data packets traverse through PC to server and vice versa.